Hello Math 6 students, it's Mr. Giomini coming to you with some review from lesson 4.1 today, which we talk about equivalent fractions. I always hear the word equivalent and I hear I think of equal. So we're talking about fractions, two fractions that are equal to each other. So if I read the directions here, it says find an equivalent fraction by multiplying. So I'm going to make equivalent fractions by multiplying. Now remember what we talked about today in class. When I'm working with fractions, it becomes a tendency, whatever I do to the top, I do to the bottom. Or, to be more specific, whatever I do to the numerator, I must do to the denominator. So if I have the fraction 4/5 here, and I use multiplication, well, I can multiply both numerator and denominator by any number I'd like. I tend to like to keep it simple, so I'm just going to multiply both by 2. So whatever I do the numerator, I must do to the denominator. So all I do is I go, hey, 4 times 2 is 8. 5 times 2 is 10. So 4/5 is equal to 8/10. These two fractions are the same. This is just in simplest terms. This is not in simplest terms. If I divided now both by 2, I'd get 4/5 again. So if you have 4 out of 5 right on a test, you have an 80%. If you have 8 out of 10 on an assessment, you have 80%. These two fractions are equivalent to each other. Remember, I multiply the numerator by 2, and whatever I multiply the numerator by, I'm going to do the same for the denominator. If I take a look at the next one, 7/10, I'm going to again pick any number I want. Let's this time pick a 3. Notice I'm not picking 1 because that would give me the exact same fraction. So I go 7 times 3 is 21. I go 3 times 10 is 30. This will help us too when we multiply fractions. Notice I'm multiplying numerator times numerator, denominator times denominator. 21/30. Again, if I were to simplify this, or reduce this to simplest terms, I would divide both by 3. I'd again get 7/10. Take a look at 1/4. Let's multiply both by 4. Both multiply numerator by 4 and denominator by 4. 1 times 4 is 4. 4 times 4 is 16. If you have 4 out of 16, you have 1/4 of the assessment, right? Which is 25%. Same as 1/4 here. I'm going to skip these next 3. Let's find equivalent fraction by dividing. Here we come to the hard part. This is actually when equivalent fractions by dividing. What I'm really doing here is trying to simplify to reduce to simplest terms. So I look at 9 and 12. I think about what are the factors of 9? 1, 9, 3. Those are all factors of 9. 1 times 9 is 9. 3 times 3 is 9. So I need to divide both numerator and denominator by one of these 3. But only one of these can really help. 1 doesn't help because 1 divides everything and it'll just give me back 9/12. I cannot divide 12 by 9, so I'll get rid of that. I will try 3. So whatever I do to the numerator, now I'm going to do dividing. So again, finding equivalent fractions by dividing. So I divide both numerator and denominator by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. 3/4. Again, if I times both 3 and 4 by 3/3, I'd get 9/12. These fractions are equal to each other. They are equivalent. Okay, I look at 20/100ths. Let's see my factors of 20. 1 and 20. 4 and 5. 2 and 10. Okay, 1 goes in everything, so I don't care about that. 5 will go into 100, yes. 2 will go into 100, yes. 10 will go into 100, yes. 4 will go into 100. 20. I'm going to pick the largest, their greatest common factor. So I'm going to divide both by 20. If I divide both by 20, 20 divided by 20 is 1. 100 divided by 20. Let's see here. How many times will 20 go into 100? 20, 40, 60, 80, 100. Hey, that's 5 times, so that's 5. So it's 1/5. So 1/5 is equivalent to 20/100ths. If I take a look at the next one, 4/16. List my factors of 4. 1, 4, 2. What's the greatest factor? Greatest common factor goes into both 4 and 16. 1 goes into everything, so I don't care about that. 2 will go into both because they're both even. Will 4 going to say, yeah, 4 will. So I'm going to divide both by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. So 1/4. 1/4 is the same or is equivalent to 4/16. Say, look at some other skills. Write 3 equivalent fractions for each number. Oh, I have to write 3 of them now. So let's just times both of these by 2. That would give me 2 6. Okay, let's now multiply them both by 3. That would give me 3 9ths. Let's multiply both by 4. That'll give me 4 12ths. Again, whatever I do to the numerator, I must do to the denominator. Now, what this means, boys and girls, is that all of these fractions here are the same. 1/3 is the same as 2 6, the same as 3 9ths, the same as 4 12ths. They are all equal to each other. Yes, I know they have different denominators and different numerators, but these fractions, these 4 right here, or these 3, I'm sorry, are not reduced to simplest terms. If you were to reduce simplest terms, you'd get 1/3. That doesn't mean it does not equal 1/3. When you reduce, you're actually finding what that fraction equals in simplest terms. So the numbers are both relatively prime, as close as you get to being prime. All right. If I take a look, 75 hundredths. What goes into 75 and 100? Now, I don't even multiply these. I guess I can multiply both by 10. And that would give me, because it doesn't say how I have to find the equivalent fractions. That would just be 750 over 1,000. I could divide both by 25. 25 divided by 75 is 3. 25 divided by 100 is 4. I could also divide both by 5. 75 divided by 5 is 15. 100 divided by 5 is 20. Again, all 3 of these fractions, or all 4 of these fractions, are equivalent. They're all equal to the same thing. One way I could prove that is to get out a calculator and say, hey, 75 out of 100. Well, if I have 75 out of 100 on a test, we should all know that that's 75%. Okay, let's see. What is 750 divided by 1,000? Hey, that's 75 hundredths, or 75%. Let's 3 divided by 4. Hey, that's 75 hundredths. What is 15 divided by 20? Hey, that's 75 hundredths. There's another way to check to make sure all your fractions are equivalent, because they should convert to the same decimal, same percent. All right, last one here. Write each fraction in simplest form. Write each fraction in simplest form. So now I need to reduce these until they can't be reduced anymore. This is where we struggle. Okay, I always look at the smaller number, which in this case is the numerator. And I ask myself, can the numerator be multiplied by anything to get the denominator? Yeah, what times 8 is 16? 2. So that means 8 goes into both. So now I divide both by 8. 8 divided by 8 is 1. 16 divided by 8 is 2. When I have the numerator and denominator within one of each other, I can't reduce that anymore, I can't simplify that anymore, so that's 1/2, I'm done. Okay, 6 9ths. Well, I could look again at the smaller number 6. I can't multiply anything times 6 to get 9, so my strategy back here won't work. But I can list my factors of 6. Well, we could do a factor rainbow. 1 times 6, 2 times 3, nothing times 4 will give me 6, nothing times 5. So there's my factor rainbow. Now, what is the largest factor of 6 that also is a factor of 9? Well, 1 goes in everything. I don't care about 1. 2, no, because 9's not even. 3, yes, 3 will work. 6 won't work. We've talked about that. So I'm going to divide both by 3 to simplify this. 6 divided by 3 is 2. 9 divided by 3 is 3. I have 2/3. Now again, these fractions are equivalent. 8/16 is the same as 1/2. 6 9ths is the same as 2/3. When you're reducing to simplest terms, you're finding equivalent fractions. You're just making it as small as it could possibly be. The numerator and denominator as small as it could possibly be. You're not changing their value. You're not changing the value of the fraction. 3/15. Again, I look at the smaller number, which is 3. Any times 3 give me 15? Yeah, 3 times 5. So I will divide both of these by not 5, but by 3, because 5 will not go into 3. So if I divide both by 3, 3 divided by 3 is 1. 15 divided by 3 is 5. That is simplest terms. I am done. I go here, 10 25ths. I circle the numerator. That's the smaller one. Anything times 10 will give me 25? No. Let's list the factors of 10. 1 times 10 and 2 times 5. Okay, 1 goes into everything, so I'm not worried about 1. 2. Will 2 go into 25? No, 25 is not even. Will 5 go into 25? Yes, it will, because 5 times 5. Will 10 go into 25? No, 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30. Nah, it won't work. So 5 is my greatest common factor, so I'll divide both numerator and denominator by 5. 10 divided by 5 is 2. 25 divided by 5 is 5. 2/5. which is the same or is equivalent to 10/25. Okay, I'm going to stop there. Hope this helps you out a little bit. This is a great review for lesson 4.1, equivalent fractions. Take care.